Today, I will introduce the second section of this database storage to you. It's about the heap file structure, and some of the settings of the heap file structure, configuration, and an organization method, including a particularly typical which is used a lot in mainstream databases. That is, a log file storage. The main logics and some of the related operations of the log file system. Because CnosDB is also based on the log file storage of the log file store system. So we are going to elaborate on that as well. And today, we are going to talk about storage. This second lesson is storage 2. In the last lesson, we mainly carried out some basic concepts of data storage, including how to set up some basic structure of the storage on the hard disk. The outline of this section mainly includes 5 parts. First of all, this is a page-based storage structure. That is, how the page is stored in the database disk, and then its heap file. That is, the heap file of the heap structure of the heap in a number of ways, including the page layout. And then we will talk about the log structure, log file system. That is, log file system, how to work in the whole disk storage. Finally, we'll talk about its internal tuple structure, as well as in the tuple for the relational structure of some of the pre-processing. This is the main outline of today's session. Okay, about the page storage structure. In fact, the DBMS database management system, there are different ways to manage the corresponding pages in the disk, but also according to the sequence of the file organization to arrange the page. You can also keep the way, that is the heap sort of way, the organization of the file. And then we'll probably talk about hashing or index sequential access method, or ISAM. But today we'll explain how a DBMS manages the pages in a disk file by keeping the file organized. A heap file is primarily an organized collection of one page, and we can imagine this page as an ordered collection. Then the tuple is the tuples in a random order stored in this page. We want to support 2 operations. The first is that we can CGWD in the heap file system. That is, create, get, write, delete. Create and read or write or delete the corresponding page, CGWD. We talked about these page files in the previous lesson. Page is the basic structure in the disk storage, but also support traversal of all the pages. If it's a traversal to get all the pages, then the heap file needs to support that. Secondly, the heap part of the heap file needs to have some metadata to track which pages to exist. To find out the exact pages and which pages are still available in these pages, to find these available spaces and to get to these pages, and then to write the new tuple data to this page. Then it also needs this metadata to manage these pages and available space. The bulk is a heap file system to do some of the corresponding support operations. There are 2 main ways to implement a heap file. The first is the very familiar structure of a chain table. The header of the chain table structure has a pointer to a free page. That is to say, we say free in the free configuration list. One by one, the corresponding situation. I use a pen to draw this free page list. It is a record in the list of which page is still free pointer. And then the database is looking for a particular page. It needs this order to scan the page until this position is found. There's also a reserved page, a data page list, which is pages of data that have been used. This use list also keeps a pointer to the number of slots available for each page. That is, each page also defines how many of its own slots are available in the data, and then defines the slot. That is, records the slot, and then the free page list is a pointer to a completely empty page list that can be used. The free page list is completely empty pointer to a page that can be used. In the whole list, if our database finds a specific page, it will traverse in a sequential structure. First, find the first number 0. If not, then find the second number 1. In fact, it is relatively inefficient, so we will have a new way to optimize the operation. Then here comes the heap file operation. The corresponding operation of the page literal point of the heap file is that I use a dictionary to record the corresponding page. In the main database, I maintain a special page. This dictionary is actually a page. This special page stores the location of each data page. That is, each data page in which the corresponding position will be stored in it. For example, if part of this data page is free, then this directory keeps track of the number of slots that are available on each page and then makes sure that those records are synchronized with the data page. So when I go to do an insert, I can first find the page in the dictionary, and the dictionary also keeps track of how many slots are available on that page. So if I call that page space, I can write the tuple to that page. Once it's full, I will just request another space and direct the page. And that's how the dictionary in the heap file is used. So this is the heap file of the two ways to use. One is the chain table. The disadvantage of the chain table is that to find the page words how to do traversal of the way. Dictionary advantage is that it can guarantee synchronization without having to traverse to find the corresponding available page. And then again, in this page, for data phase, create, write, delete, enter, and other related operations.